In this session, you will acquire the basic understanding of why a floating unit is either stable or unstable, how to avoid the unstable conditions, and the basic understanding of what makes a unit either float or sink. After completing this session, you will know how to measure the initial stability of a unit. Additionally, you will learn the fundamentals needed to do accurate calculations of stability and flotation. The first lesson introduces the basic definitions of stability states, lull angle of inclination, and motions. After you finish this lesson, you'll become familiar with the 3 states of stability and the 6 possible motions of a floating unit. The shown jack-up unit is afloat in its upright position. To define the various stability states, you will apply momentary forces on this unit and investigate its resulting behavior. These external forces could, for example, represent the effects of winds and waves.
Let's see what happens if we apply a momentary external force on the floating unit and observe its behavior.
Positive stability is the ability of a floating unit to return to its original equilibrium state after being inclined by an external force.
A floating unit is considered to be stable at the upright position if after applying a momentary force the unit A. remains inclined, B. returns to its upright position, C. continues to incline. In the previous topic, you became familiar with the definitions of positive stability or stable equilibrium. Both are the same.
Neutral stability. Let's see what happened if we apply a momentary external force on the floating unit and observe its behavior.
After being disturbed by an external force, the unit does not have the tendency to return to its original equilibrium state. The unit remains in the position to which it was inclined.
Negative stability. Let's see what happened if we apply a momentary external force on the floating unit and observe its behavior.
After being disturbed by an external force, the unstable unit continues to incline further away from its original equilibrium position. Note that when the unit is unstable, it does not necessarily need to capsize.
Let's see what happened if we apply a momentary external force on the floating unit and observe its behavior.
After being disturbed by the external force, the unit continued to incline to an angle where positive stability is restored. This angle is known as the lull angle. Note that with respect to the upright position, the unit has negative stability. It is unstable. However, with respect to the lull angle, the unit has positive stability. It is stable.
A floating unit is considered to be unstable at the upright position if after applying a momentary force the unit A. capsizes and sinks, B. returns to the upright position, C. capsizes or inclines to a new position.
A floating unit has 6 types of motions. 3 of those are defined as angular motions, and the other 3 are translational, linear motions.